So yeah, I'm going to be talking about mitigation and 4 degrees C, but someone's already used the nautical term nailing your colours to the mast. So I'll nail my colours to the mast. We should not go to 4 degrees C, we should not go to 2 degrees C, we should be aiming at 1.5 or preferably 1. That's where we should be going, and we should be making every effort we can possibly make to go in that direction. But we're not, so we're here today to talk about 4 degrees C. Some of this was put together at 10 to 3 last night, so I can't promise how smooth some of the bits will be. It's based on some work we have been doing, but we hadn't got the final plots together. So I was doing that last night, and they came through early this morning, so I can't promise quite how smooth they'll run. What I want to look at here over the next, however long I've got, is some of this is based on a talk I gave extra about a year ago, and I apologise, but I think it's important to set that as a backdrop to the rest of the talk. Just a little bit about climate change, dangerous climate change. We've heard a lot about cumulative emissions, and I think it is really hopeful that that is becoming the language of the scientists, because for far too long the scientists have talked about reductions by 2050 by X percent. So I think it's really good to see that, and that is a whole new chronology of climate change. Misplaced optimism, ignoring the bean counters. These are the train spotting types that count up the CO2 molecules that scientists never bother to communicate with. And I'll say a little bit about that later. Look at some global greenhouse gas pathways, and the future is impossible, whichever way you go, but we've got to make one of them possible. Say something about non-Annex 1 emissions, and then look at what's left for us. And I think that's probably the right way of looking at it, rather than the other way around, which is how we've traditionally looked at these things. They say something about what's the scale of our responses to this issue. So, someone just collared me at dinner and was concerned about this issue of 2 degrees C, that we're using this almost like, well, that's fine. Well, certainly the EU and the UK defined dangerous climate change as 2 degrees C, and you know all a bit about mean temperature and all the rest of it, but that's the sort of number we're heading for above pre-industrial levels. But let's be blunt about that. That will kill people, and that's probably already killing some people around the planet, and it will kill a lot of poor people in the southern hemisphere. But we've never cared about them in the past. We've pretended to, but we haven't really cared about them. We've never cared about the stresses they've gone through. We're happy to sell them weapons or give them dams, regardless of whether they're appropriate. But let's be blunt again, that 2 degrees C will kill some of those people. But we think we can get away with it in the northern hemisphere. So we say that's dangerous. But it is already, that's the threshold between acceptable and dangerous. It is not acceptable to many people around the planet, regardless of how good your economic analysis is. Things have changed. 2 degrees C seems to be the worst end now. The burning ember diagram has adjusted considerably. There's a lot more discussion now around ocean acidification, and even at these sort of ppmv values, I gather there's some quite serious implications that might arise in terms of ocean acidification. And at last, people are starting to say, actually, look at where we're heading, and it doesn't look like 2 degrees C. It was heresy to question this until just recently. Now, I've been ridiculed time and time again for saying we're not heading towards 2 degrees C. But at last, it seems to me that there is a general view now that we are going to go well above it, or very likely, unless we make significant changes. So the agenda has shifted, I think, somewhat over the last year or two. Going to put bluntly here, I think that 2050 targets are unrelated to dangerous climate change. Where's Miles? Is he around? Yeah. I wasn't quite sure how that linked to your talk, but I think this discussion about an 80% reduction by 2050, we can all achieve that by just doing what we're doing now, and just have a quick agreement that just before midnight in 2049, we just don't do anything for 5 minutes, and we'll meet the 80% reduction by 2050. So, but that doesn't help us at all. It is those cumulative emissions. It fundamentally changes everything that we look at. So that's what matters. Carbon budgets, greenhouse gas budgets, call them what you will, and that rewrites the whole chronology of climate change. And this is why I think it's unpopular. Why it's been hard to get the shift to cumulative emissions. Because underneath it all, we know it's about us, about our responsibility. For the politicians, 2050 is not in my term of office, so they love that because they can pass it on to the next people in Parliament. But we love that as well, because we can just pass the responsibility to our kids. They can solve the problem in the future. But actually, if you look at cumulative emissions, it says, no, the politicians have got to respond now, and we have to change our behaviour this afternoon. And we don't like that, because we don't want to change our behaviour, and the politicians don't want to have to act either. So there's a sort of a big agreement here, consensus of us trying to say it's someone else's fault in the future. And cumulative emissions does not allow us to do that. That changes the agenda significantly, and it also reduces the value of technology in the short to medium term. So towards urgent and radical reductions that we need. And that's why I keep banging on about behaviour, despite the fact that I love technology. Because we have to get the behaviour to change our emissions very rapidly indeed, to give space for the low carbon technologies to come in place as we proceed out from 2020 to 2030. So how does this challenge, this scientifically credible way of thinking about the challenge, alter what we have to do? in the Tyndall Centre, we've considered a series of scenarios using the best science we can find out there, and we may have misunderstood some little bits here, some numbers maybe not quite match with Jason or Miles or other people's work there, but broadly the message holds from what we're saying here. We've looked at CO2 emissions from land use, significantly influenced by deforestation. We've said a little bit about feeding people on the planet, because we think it's not a bad idea to have a bit of food. And then we've said, once you've got those things, what space is there for us to fly around the world to conferences? What space is there for energy? And we've used all of the standard forms of data, so we've not been looking for obscure data sources. It's all the usual sorts there. All right. Now, if we look at the forestry bit to start off with, the forestry, we were very optimistic both in terms of forestry and food, and we've been criticised for being too optimistic on both of these, but the whole plan of looking at these scenarios is to say, well, let's imagine we really are going to try to actively move towards a much lower carbon future. Then we really must look at all sectors, including deforestation. There's a huge error bar, as you can see there. I mean, currently that's the sort of range of emissions from forestry. That's an enormous error, and we really need to try to get a tighter handle on what that might actually mean. And what we proceeded to do from that was to say, of the total amount of carbon that's locked up in trees, how much of that will be released to the atmosphere over the next 100 years? And they're the two scenarios we used. That's the best one we could find in the literature. That's where we are today, and we took a few plots from the points that people mentioned out into the past. And obviously it's the cumulative, it's the integral, it's the cumulative emissions under here that matter. So that's the best one in the literature, and that's 70% of the forest carbon remains locked in the forests. And that's one we say, well, let's go a bit further, let's go to 80%. And we've been criticised for saying that's too optimistic, but as you'll see later, it's actually, even that isn't really enough. And we then went to look at food, and assuming we had 9 billion people on the planet by 2050, and of course there's no certainty of that, but certainly we're moving in that direction very rapidly indeed. And what we did here was take EPA data going out, and then we were saying we need to very rapidly bring that down to a level by, say, 2050, where our only real significant emissions here are from food, and there we assume 7.5 gigatons CO2e from food production. The Committee on Climate Change assumes 6 tons, but it gives you some idea of what is actually feasible to achieve with a 9 billion population. Both the 6 and 7.5 are very challenging, and that's currently half the food intensity of what we eat now, so that's already very challenging. So the whole idea of agriculture behind this is a significant reduction from where the emissions are today. So perhaps an increase in vegetarianism, a change from rice to other crops and so forth. And then we said, right, what peaking dates should we use? And I probably disagree slightly with Miles on this. I think the peaking dates are important because they're only important as they're plots on the pathway, if you like, which is the pathway that surrounds the cumulative value. So they're important in that way. And we can better discuss this later. But the Stern report used 2015. The CCC used 2016. And we thought 2020 might be one we should look at, global peaking, and 2025. I mean, clearly it's much easier if you use 2004, but we didn't peak then. So the peaking issues are important in that sense. We can't peak in the past. So there's one element of that's some validity. And then I think the next thing to do is just to chat to the people wearing raincoats, the people that actually count up the CO2 molecules. And scientists don't like talking to these people. They haven't done it historically very well. That's why most climate scientists know very little about climate change, because they never engage with the people who collect the emissions data. And I think there's a real big difference between those two, and I'll come back to that in a minute. I won't ask. If you ask scientists, including some really eminent ones from some major research organisations, what the emissions are for their country, or what the global emissions are, or what the trend data is, they can't get it within an order of magnitude. Now, I think that's what's worrying, because they're asked all the time for their expertise on climate change with no understanding of the emissions. And that there are some notable exceptions to that. So let's factor in the emissions data. Well, firstly, this is a curve I put up time and time before, and you must have all seen this. Things are getting much worse. In fact, since 1992, and the Earth Summit has got much worse since 2000, when we've all been rambling on and travelling around the world talking about climate change. Emissions have really gone up. So since 2000, emissions have gone up at a faster rate than they have done historically. So the more we talk about climate change, the higher the rate of emissions goes up. And there might be a correlation between those two. So that's what the emissions data is doing, and actually everything you plot for human beings does this. And any other species that you found that, you'd think it was good, somewhere off here it would drop off the cliff and it would be a genetic cul-de-sac. But somehow we think we can get out of it. The latest magic bullet is geoengineering. It was biomass a couple of years ago, and then nuclear fusion before that. So what do we do about this? Well, the usual human response is to shove your head in the sand and pretend it's not happening, and then preferably pay someone very eminent to actually tell you that. This is now CO2 emissions since 2000, 2.4% per annum. there was a report produced, you might have heard of, called the Stern Report. In the Stern Report, which was produced in 2006, the growth rates that Stern had in that report from 2000 to 2006 were 0.95% per annum. That's the data the government collects, that's the data the UNFCCC collect. Why is it Stern had this? Why is it the scientific community didn't pick up the difference between those two? That difference is enormous and changes the shapes of the curves in the Stern Report significantly, and therefore would change the amount of GDP you'd have to spend to mitigate. So that has fundamental repercussions. And because the scientists never talked to the bean counters, they didn't spot the difference between the two. So that's what we do. We generally deny it's happening. It's been deliberately a little bit provocative. So what happens now when you have what I think we should put the word in there, abject failure. We have the abject failure to reduce emissions, and we link that to the science of cumulative emissions, which I think we're all broadly saying is the right way to go now. And what's that tell us about a 2 degrees C future? Well, let's look at some pathways for 2 degrees C and some assumptions behind this. Firstly, if we peek it at those particular dates up there, we're very highly optimistic on deforestation and food emission reductions, and they're the cumulative values I've used here. Now, the CCC used some that are a little bit higher than this for CO2e over the century. These are the ones that have AR4 for 450 parts per million stabilisation. So that's the range there for 2 degrees C. And we can have arguments about what's the appropriate number within that range. But we did all of those in the analysis. And that's, according to Malta Mines House's paper, and there are criticisms of that as well, that they broadly link to something like a 10 to 60% chance of exceeding 2 degrees C. And if you want to discuss that probability issue, chat with Jason later. So if we've got the emissions for food, we've got the emissions for deforestation, we know what the cumulative values are, and we've got different peaking rates, and we can start to plot what the curves are. This is all the old stuff that we've done, and some of you may have seen before. There's the 2015 one, there's the 2020 one, and there's the 2025 peak. And what you'll notice is there's less curves as you go along, because you start to exceed the budget at the lower end of the cumulative value range. So by the time you get up here, the lower values you can't hit, you've exceeded them already. So you have to rely on the upper end of the values being appropriate for 2 degrees C. So, and the curves are different because of deforestation there as well. But what you'll notice, all of those curves, they're all lemmings off a cliff. None of those match with the sort of things that economists like to see, a gradual smooth descents. They're all massive reductions very rapidly from the peak date, even 2015 is. So if we focus a bit more on 2020, which I would suggest is perhaps more in the direction that we're heading than 2015 or 2016, that's the range there, 10 to 60% exceeding 2 degrees C. That's the sort of upper end of the IPCC cumulative value here, and that's about a 10% per annum reduction in emissions. These are global emissions of CO2e from 2020. It comes down about 10% per annum. So unless you can achieve 10% per annum, or your geoengineering options work, or your Harry Potter's wand works, or some other technique works, then it seems to me you have to either accept the fact you're going to exceed 2 degrees C, or high probability of it, or you have to find some way of achieving this, which I think is actually doable, but we're generally told it's not. If you now take out the take out the food emissions and take out the deforestation emissions, the bit that we're actually really interested in most of the time, most of the discussion on mitigation is about energy. It's about power stations, about biofuels, or about flying and ships, we've heard today as well. What's left for energy? Well, firstly, 13 of the 18 scenarios are impossible. By the time we've removed the optimistic deforestation and the optimistic food, there's no space for energy left with many of the scenarios. But there are some. And if you plot those out, these are the ones that are left, and you have to have complete decarbonisation of the UK, of the global energy system between 2035 and 2045. And as I say, this already assumes that you're at the upper end of the cumulative range in AR4, which I admit is lower than the ones that have been used by the Committee on Climate Change. That looks challenging, I think, to say the least. I think it looks doable, but we're not prepared to do it, or not so far. So the question would be, well, what about 3 and 4 degrees C? Well, if we assume now 2020 peak in emissions, highly optimistic deforestation again, and a 50% chance of exceeding 3 and 4, and that's really quite vague as to quite that percentage chance there in this, because it's very hard to get really robust cumulative values for all that. But if you use the cumulative values that we picked out in Stern, and we're discussing with Chris Jones, for energy alone, for 3 degrees C, which some people would suggest is sort of livable with some sense of humanity still existing, you would need 9% per annum reductions from CO2 if you peaked in 2020. So that looks just about livable with to some people, and that looks virtually impossible to virtually everyone, particularly economists. So you then say, well, let's go to a higher temperature, 4 degrees C. Many people would suggest 4 degrees, you might get some human beings living there, but it may not be something we would call humanity. But it's possible that we could live there. But it's not a world to me that resembles something that I would say is a success for the human species to have actually got there. But 4 degrees C, and that requires a 3.5% annual reduction from energy emissions. So that is just about doable if we can live there. But can we? You might be able to live there, but we can't get there. So the future does look actually impossible looking at it from that. Now, against that backdrop, this is work that we've done before, and what I want to do now is actually to start to split the world up a little bit, to give a bit more of a nuanced interpretation of these global figures. And even this is a very simple split between non-Annex 1 and Annex 1 nations. And as you know, non-Annex 1 covers a huge array of different states of industrialisation for the nations within it. But let's use that as the split. If you have a fair deal for Annex 1, and of course fair here depends on people's views of that, what's left for us? That is how that slide should read, really. There's the Annex 1, non-Annex 1. That's them crossing here just a few years ago. So the Annex 1, the non-Annex 1 now are emitting more than the Annex 1, but of course, the population of us is quite small. Other people must know better than me, but I think we're about 1.4 billion of the 6.8 that are out there. So we're very small. The Annex 1 are quite a small proportion of the total population. Let's use assumptions here. Cumulative values here, I'm going to use the upper end of the IPCC range, so we're already at the optimistic end of that range. The very optimistic deforestation scenario. I've taken the more optimistic food scenario, so I've gone right down to the CCC's one, that we can actually survive on 6 gigatons per annum, which is, I think, well under half of what we currently use per annum. Yeah, sorry, if you work it out per capita, it's well under half what we're using per capita. And this is now for a 9 billion population. And this gives you roughly, if you take the malted paper and take that cumulative value, a 21 to 60% chance of exceeding 2 degrees C. So these are the background assumptions to that. And a 9 billion population, which I've split between 2 billion for Annex 1 and 7 billion for the non-Annex 1. You can adjust these assumptions as you see fit. But if you do that with these, you come up with some curves that look a bit like this. If you add those two together, that's 6 gigatons, that's feeding the world. And maybe there are ways around that, but this already looks enormously challenging, and we are finding it very difficult to know how you move to really, well, certainly to zero carbon or zero methane emissions agricultural systems. This is still highly optimistic, and I think at the moment we should not be thinking of this going to zero, not this time. Maybe out here perhaps, but it's a long way away. I mean, even fusion power might be out here. Right, so let's look at some numbers in this. I'm having to assume here already, this is for the non-Annex 1 countries here, I'm already having to assume that they've reduced their historical growth rates that we've seen since 2000, ignoring the banking crisis as if that's a blip, but it may or may not be. But that throws a spanner in the works of all these sort of analysis, or at least I suppose a small blip like that usually. But 3% per annum is below the historical growth rate, so that's already been quite optimistic. I'm assuming that the non-Annex 1 countries here will peak in 2025. Does anyone here think that's likely? Right, so that's obviously a bit optimistic. So this is peaking in 2025. You listen to what President Hu said recently, and his announcement said that the Chinese would significantly reduce their carbon intensity by 2020, but not their absolute emissions. And the best estimates we can get are about 2030. It looks as good as we can get for China. But we've said here, let's be more optimistic. Let's imagine that all of the Annex 1 can collectively peak by 2025. Then they have a 4% per annum reduction to start off with. Then it moves to 6% per annum reduction, and then to 10% per annum reduction. Now, I don't think that's necessarily reasonable to impose that sort of future on these parts of the world post-2025. But you can't get numbers to work otherwise. So that's massively fast reductions. And then their food section here. What's that leave? And their fully decarbonised energy system by 2050. So the non-Annex 1 countries have no energy emissions, carbon emissions by 2050 under this, to meet the upper end of the cumulative values for AR4. We then say, well, what about us? What about the Annex 1 nations? Well, let's imagine, that's wrong to start off with. So that was peaking in 2011/2012. So this is probably doing it late at night. That number's right though. So we're peaking in 2011/2012 in the Annex 1 countries, and that looks doable. We could actually do that. The UK's dropped a bit already by exporting our emissions to elsewhere in the world. Well, that's exactly what's happened. I'll show you that later with the DEFRA curves, but that's what we've done. And other countries are trying to do exactly that. So imagine we peak, then an 8% per annum reduction by 2015, and a 20% per annum reduction, 20% per annum reduction by 2020. Fully decarbonised by 2026 to 2027. And if you add those two together, that gives you the cumulative value, 2,200 gigatons, the upper end of the AR4 range. Now you have to think whether that's viable, whether that's doable in any shape or form. That is a relatively high probability of exceeding 2 degrees C, however you play around with the numbers. So let's revisit that now for 4 degrees centigrade. The same sort of analysis. Now here, I was doing this till very late last night, and is Jason around? He's gone. I can blame him now. I spoke to Jason Lowe last night. I've been trying to get hold of a cumulative value for 4 degrees C. I'm just an engineer. I just want a simple number. Give me a number or a range of numbers. And he gave me around about 4,000 gigatons. And I noticed that, Miles, you had 3 in yours for 4 degrees C, one of your plots that went up. It had 1, 2, 3, basically, for gigatons for the...
Yes.
Yeah.
But I already said that I didn't... Well, it's Carmack's on the left.
No, it's Carmack, right. Anyway, he gave me 4,000 to play with. I think that's hugely optimistic, and he said it was anyway, because there are issues about the carbon sinks being affected. But let's pretend that the world is a really optimistic place. And that's the amount I ended up playing with that comes out of the curves I'll show you in a second. So let's do this now for 4 degrees centigrade. I'm just guessing, I would put a big question mark. I would like to know from the climate scientists what probability that sort of number gives you exceeding 4 degrees C, if probabilities are in any way useful in thinking about this here. Optimistic again for deforestation, but not quite as optimistic. That's the best one that's currently in press, other than the one that Alice and I produced in our paper last year. So it's that 70% of the carbon in forests remain in 2100. I've now increased the food emissions to 10 gigatons per annum, a small increase, but still hugely optimistic, and have remained with the same population here. So let's run that one through. They're the curves that come out of this. And again, you can play around these curves a little bit to meet those cumulative values. Firstly, the growth rate is slightly higher here, still below what we've seen from the non-Annex 1 countries, which are typically just over 4% since 2000. They're peaking now in 2030, which I think most people would say that looks optimistic, but certainly doable within the current framework of how we may think about these sets of issues. And China there are certain parts of the Chinese government, certain ministries that have suggested that may not be an unreasonable peaking date. But of course, Africa might have come on after this, and India as well. But let's assume they can all peak around 2030, in aggregate at least. And then come down at what the economists tell us is the only sort of the highest percentage reduction rate we can get while still having a burgeoning economy, if you think that's a good thing. And they tell us broadly 3%. I'll come back to that later. So a 3% per annum reduction can be allied with a growing economy. So I've used the economists' reduction rate here. That's typically used. Stern used that. The CCC used that number. Actually, Stern did point out anything above 1% has only ever been linked to economic recession and upheaval. But he thinks we can get to 3% per annum. So what does this now leave us for the Annex 1 countries? Well, we peak in 2012, and then we reduce at 3% per annum again. I've tried to say what the economists say we can do, and that's what the CCC have said for the UK. We decarbonise, if you follow that through, it all fits quite nicely. You decarbonise at roughly 80%, 76% it works out at, by 2050, which is actually often the figure that we hear. So this looks to me to be all of the things we've set in train working. And if it does, that gives us about 3,800 or so gigatons over the 21st century, which puts you well in the 4 degrees C range. So if we do everything we say we can do, and we're failing to do anyway, then we might have a chance of 4 degrees C. That's what seems to come out of this. And that shows why we need to go somewhere much further. Now, that's the scale of the challenge, and we can argue... You can argue a little bit with the numbers on that, but let's just run through that quickly as where we go from here. Right, how are we faring against this? The UK, all credit to the UK, in many respects, I think the UK is leading the international rhetoric on climate change, and we need the rhetoric. I don't mean that as a criticism. You need the rhetoric before you get any reality that comes out of that. And so the rhetoric is an essential part of that process. And I genuinely mean this as a compliment. The UK is leading on that. And I think it's leading now on some of the policy outlines that are necessary, like the Committee on Climate Change. The actual policies are a little way off yet. That's from the low carbon transition that came out just a few months ago. Notice that global temperatures must rise no more than 2 degrees C, must rise. Right, that's us taking some sort of leadership there. Look at the Committee on Climate Change report. Their cumulative values, firstly, are aimed at that sort of level, that sort of probability of exceeding 2 degrees C. That's what they claim in their report, Committee on Climate Change. But that includes cooling aerosols, but doesn't include any warming from, say, the NOx emissions from the back ends of planes, let alone vapour trails and contrails. But it still takes, I would say, a slightly optimistic view of the cooling element and ignores some of the warming elements. And Jason and I were talking about that yesterday. But can that sort of percentage be reconciled with must not rise more above than 2 degrees C? These are different probabilities. Is that important? The CCC, if you run the CCC's cumulative values through Mindshausen, they're the probabilities of exceeding 2 degrees. But what matters is that links to a 3% reduction in carbon emissions or greenhouse gas emissions for the UK as we go on out into the future. But if you change the probabilities, All we're doing is tweaking the probabilities for 2 degrees C. You can describe all of this as 2 degrees C. 9% is a tad more tricky if you're a policymaker than 3%. And all of these are just change the probabilities for 2 degrees C. Exactly the same analysis holds in the CCC stuff otherwise. So the probabilities, the devil is in the detail there. And it's interesting, we're prepared to accept much higher chances than would come out of the language that's in government. We've actually got a briefing note on the Tyndall website about that subject now. What are current emission trends for the UK? Like every other Annex 1 countries, pretty much. Despite the fact our emissions have gone down within our boundaries, our lifestyles are higher carbon emissions today than they were in 1990, and I'm sure every one of us fits into that category as well. So not surprisingly, emissions in the UK have gone up by 18% since 1990 from our lifestyles, just that we happen to call it Chinese emissions now. So what's the best example we have out there? We are the best example in the UK, and I'm holding this up here. Well, I could be knocked down later, but I'm holding this up as a good example. 30 to 80% chance of exceeding 2 degrees C, very optimistic peak. We're going to buy out loads of our emissions, 17% in the current budget we've adopted. If we adopt the other budget, 27% of the effort we have to make we'll buy from Ghana and Nigeria, which I don't think is necessarily very reasonable. We've only had a very partial inclusion of aviation and shipping emissions, and we've seen how important they were earlier today, and real emissions are up 18%. That's the best example out there. Compare that with the challenge I laid out earlier. And what of the rest? Well, the Waxman-Markey bill, for what it's worth, no reductions from the US indigenously by 2017, once you strip away the lawyer speak behind it. A 4% reduction by 2020 from the US, 4% from the US by 2020. Japan, gone from 8% now to 25%. We haven't had a chance to look at the details as to what that means yet, whether there's any buyout in that. Russia and New Zealand, I still think, have no targets. In fact, the new New Zealand Prime Minister, as I understand it, doesn't really believe in climate change. China and India, they demand big reductions to the Annex 1 countries. I don't think they call 4% a big reduction. And lots of the LDCs, as we patronisingly call them, they suggest we should include historical emissions as well. And this is just far removed from whatever the science is telling us. So, I will finish then, I think my time's up now, with this. I'm not paying this chap any commission, but it must be the 1,000th time I've used it. And I think it captures what we need now. At every level, the greatest obstacle to transforming the world is that we lack the clarity and imagination to conceive that it could be different. And I would make the argument things like opening the windows is conceiving the world could be different. They can be quite small changes as very, very large changes, not opening windows, open the curtains, sorry. So I think there are small things we can do and there are very large things we need to do, but the future will have to be different, whether it's in terms of mitigation or adaptation. And morally, I think we should go down the mitigation route. So on that note, I'll finish. Thanks, Dana.